combined random variables. And variance of the combined random variables, if you remember, that only worked for independent random variables. So if one affected the other, that wouldn't be true. But we know in this scenario that me picking a guy randomly doesn't affect the girl I'm going to randomly pick as well. And it's not going to change who she is. I'm just matching up pairs of randomly males and females. It's not, one's not affecting the other. Alright, so if you want to fill in the blanks, if we were to do this during the state plan do conclude, state was already filled in for you. We're just saying, what's the probability that a randomly selected male speed data is taller than a randomly selected female speed data? Plan, you got to tell what you're going to do. Okay? So we had to define a new random variable, D. We defined it M minus F. Hopefully you understood why we did that from yesterday, because we were trying to find the probability that M was greater than F. So that has no number in it, so we subtracted F over, making it M minus F. So we wanted to find the probability that D was greater than 0. All that's in our plan. You don't have any blanks to fill in there, but you've got to know how to do that. You go to the do, since D is the difference of the two independent normal random variables. D follows a normal distribution. Notice you had to say that. So on the test, if you don't say that, you don't get full credit, because if we're about to use table A, or normal CDF, or z-scores to find the value on table A, it has to be normal. And nowhere in the problem does it even talk about D. I introduced this new variable D. So I've got to tell that it's normal. So I've got to have that first sentence. Since D is the difference of two independent normal random variables, it's also normal. Because they were both normal, and I formed it from those two normal, it will also be normal. I'd have to show how I found the mean, and how I found the variance, and thus what the standard deviation would be. So we did all that yesterday. The means were, I think they were 70 and 65. So I need to show all of this. Show the work. Don't just tell me what the new mean is. I need to know where it came from. The variance of the two, even though I'm subtracting them, variance is going to increase because I'm adding more variation. Those variances were 16 and 9, right? So then the standard deviation was the square root of 25. You gotta show all that. That's all just part of your do. Still haven't even done the problem. That's just to set it up, because that let us draw the density curve. So now we can use table A, or we can use normal CDF. We had to say that first. Make sure you've got that if you want full credit. You've got to be independent, or this doesn't work. They've got to be normal, or my next step doesn't work. Anybody have questions on what I'm saying you've got to have there?
What would we do if they were?
You won't. You just say we can't go any further. I mean, there's nothing about, there's nothing that goes that far in this course. You get to higher stats course in college, so we'll end up using. So what you're kind of using here, if you realize, this kind of looks like the Pythagorean theorem. Right? The Pythagorean theorem only worked in right triangles. It only worked certain times. You didn't have a right triangle, you had to use something else called the law of cosine. And so if you were doing it for non-independent higher level statistics class, it kind of looked like variance of d squared is equal to, and then law of cosine. It would be m squared plus f squared minus 2mf cosine of d. You don't have to know.
Good thing.
Yes. From here, so the next step in the do is up to you. You either use table A, or you use normal CDF, no matter what, you've got to have the correct notation. So what would you be writing here? What are we finding?
D being greater than D, yeah.
Alright, so what should you write? If you started like this, so notice it is. It's fine to start there. You don't have to start there. You could have started where? D being greater than 0. I don't care which one you start with, because we've introduced D. So notice, if you just said D is greater than 0 and you never told me what D was, you don't get credit. If you didn't tell me D was normal, you don't get credit. If you didn't tell me D, M and F were independent, you're not going to get credit because you couldn't have found the standard deviation. So there's a lot to do before we ever got here. Now, from here, this is where you could go one of two ways. You could either find Z-score and use table A, or you could do norm CDF. Either way. But that's that next step, that's that final step to get you to the right answer. So if you were using normal CDF, because that's the blank you've got on your notes, probability that D is greater than 0, that'd be normal CDF. Lower bound is 0, because I want to know greater than 0. Upper bound, some giant number. So they did 99,999. After the upper bound, what do you do next? Mean. Or what was the mean here? 7. Was it 7 or was it 5? 5. Was it 7? I wrote the wrong thing back there.
The other thing was 5.
72.
It was 72. Okay, there we go. It was 72 here, so this was 70. My fault. So that'd be 7 there, and you got to make sure you're marking them. That's lower bound, that's upper bound, that's the mean of D. Don't just put mean now, because there's 3 different means in this problem. Tell me which one. That's the mean of D, and then 5, standard deviation of D. You type that in the calculator, it'll give you a percentage. I don't know what it gives you. And then you have to make your conclusion. A lot of you are leaving this out. You're just saying there's a blank percent chance. Never exact. Probability, right? We expect it to be around that. So there's approximate, there's about, there's an estimated, whatever, something percent chance that a randomly selected male speed data will be taller than a female. He is randomly favored. Or you could say it the other way. And about whatever percent you get there from speedy dating couples, the male will be taller than the female. Any questions there? Anybody?
What was the big one? Was that just like the work or the lectures that you were about?
Maybe that. You know, the mean being that, the variance being that, standard deviation being that. Any questions? Okay. We're going to go to 2 specific types of random variables now. Binomial and geometric random variables. Get as far as we can. Okay, so when the conditions are just right, many real-life situations are well approximated by specific probability models. The probability formulas that govern these models only apply under special conditions. So everything you're going to learn today, you can only use in certain conditions. What we did so far in this chapter, you can use all the time. But if certain conditions are met, there are special things you can do. So we're looking at only 2 of them, binomial and geometric. Binomial and geometric. The probability formulas that govern these models apply under special conditions. You've got to check that the conditions are met. So here's the first set of conditions. A binomial setting. You can remember the conditions you need to check by fins. V-I-N-S. Fins. something is a binomial setting. You have a binomial probability model. If it is binary, meaning the only possibility of outcomes are success or failure. It has to be independent. Each trial should not affect the other trials. The number of trials has to be fixed in advance. And then on each trial, the probability of success must remain the same. The probability can't change. So let's talk about some examples of binomial settings. If I said you flip a coin, what's the probability that if you flip a coin one time, you get tails? No. I'm not asking the question. I'm saying if that was the question, that's a binomial setting. Think about why. If I flip a coin one time, and I say, what's the probability you get tails? You either do or you don't. Right? There's no maybes. There's no kind ofs. You either did or you didn't. So it is binary. You either succeeded or you failed. It's independent. Because there was only one trial. Let's say I did. Let me change it up. How about this? You flip a coin 5 times. What's the probability you get 3 heads? Is it still binary? When you
Either successful or you're not.
Exactly. So is it binary?
Yes.
Yeah, you either got 3 heads out of the 5 or not, right? Each time I flip it was either a success or a failure. There's no in between. Was it independent? Yeah, each time I flip a coin, does it affect the next flip? No. Did I have a set number of trials?
Yes.
What did I say? 3 out of 5. So I'm saying flip it 5 times. Did the probability of success change?
No.
No, right? Each time I flipped it, what was my probability of getting heads?
50%.
50%. Here's an example that's not binomial. If I said this, how many flips would it take me to get 3 tails? There's no what? There's no set number. It could take me 100 times, could take me 3 times, right? There's no set number. It is binary. I either get tails or I don't. But there's no set number. So to be binomial, all 4 have to be met. If something's binomial, there are some shortcuts to how we can find the probability. Otherwise, we've got to do what we did at the beginning of class. So the reason you should like this is because it saves you a lot of time if something is binomial. Why don't you go ahead and make sure you got your formula sheet out. Look at the back of page 1 where all those binomial formulas are. I'm sorry, all those probability formulas are. If you look at the middle of that page, you can see we've got 5 formulas. 5 formulas that we can find quickly if we just figure out something's binomial. We don't have to go through the entire process we went through at the beginning of class. If I've got a binomial distribution, I got 5 formulas. I can find the probability that something happens. I can find the mean of the distribution, standard deviation of the distribution, and some other things that you don't know about yet. So we get to use a lot of 5 different formulas to quickly do some problems if we know something's binomial. So let's get more into checking to make sure something is binomial. What's a binomial random variable? What are the possible values of a binomial random variable? And what are the parameters of a binomial distribution? How can you abbreviate this information? So here's what you need to know from here on out, because you notice on the formula sheet you see it talked about with parameters n and p. Here's what n and p are. Anytime we talk about x on the formula sheet under binomial, It's talking about the number of successes. So when I said, what's the probability we get 3 heads out of 5 flips? X would be 3. X would be 3. So the count X of successes, and where you see X equals, they're saying, what's the probability we get this many successes? In a binomial setting, is a binomial random variable. The probability distribution of X is a binomial distribution with parameters n and p, where n is the number of trials in the chance process, and p is the probability of success on any one trial. So if I said, what's the probability, what is the probability that I get 3 heads out of 5 flips of a coin? What's X? 3. What's n? 5. And what's p? 50%. Does that make sense? Okay. If I said, what's the probability that if I roll a die 10 times, I get 3 2s? So if I said that, what's X? 3, not 2, right? Because I'm looking for 3 2s to occur. Does everybody understand that this is binary even though it's a die? How many sides of a die are there? 6. But if I said the probability you roll 3 2s, you either roll a 2 or you don't, right? Okay, so it's binary, or it's binomial. So again, roll a die 10 times, probability you get 3 2s. What's X? 3. What's n? 10. And what's p? 1/6. 1/6. Okay? So you could already find that probability right here. I may not know what all that means, so we're going to look at it today. That formula, you've got everything you need now. You know what k is, it's 3, because x equals 3. You know what n is, it's 10. You know what k is, it's 3. You know what p is, it's 1/6. You know what k is, it's 3. You know what p is, it's 1/6. N is 10, k, 3. Now you just got to figure out how to use that thing. Alright, so binomial settings. If I say toss a pair of coins 30 times, count the number of heads. N's 30, P's 0.5. The book sometimes will use Q. Q is just this. Q is just 1 minus P. I probably won't use Q much because the formula sheet doesn't use Q. Q is just 1 minus P. It's the probability of failure. The probability of success. There's no X given in number 1, right? I just say count the number of heads. I'm not asking you what's the probability we get 5 heads, 15 heads, 2 heads. There's no X. There's nothing to do here but the set number of trials will be 30. Probability of success is 50%. Go to the next one. For a particular family, the chance the child has type O blood is consistently 25%. Genetic research suggests that children receive genes from each of their parents independently. The family has 5 children. Count the number of children who have type O blood. What's the probability of observing exactly one of these 5 children having type O blood? Before you start trying to use the formula sheet, you've got to check and make sure it's binomial. So let's first go, is it binary?
Yes.
Yeah, they either have type O or they don't. So it's binary. Is it independent? How do you know?
Because it's like,
It says it. You'd have no idea here if it didn't say it. Unless you just had the scientific knowledge from some other class that it's independent. Right? Here we know it's independent. I'm tossing a fair coin. It says fair, so they're independent. Here they say it's independent, so it is independent. Third thing you check for is number. Is there a set number here? Yeah, 5, right? It says 5 kids. Is the probability of success the same every time? Yeah, it says it's 25% and it's set independent, so it doesn't change. Okay? most common mistake you could make. You read that, because I don't think there's any blanks there. Just read it as I read it. On many questions involving binomial settings, students don't recognize that the binomial distribution is appropriate. Time and time again, they throw in a binomial question on one of the free response of the AP exam, and it just gets left blank because you tried to do what we did at the beginning of class. Where you're trying to draw a normal distribution curve, and you just can't figure it out because there's not enough information. If you get stuck on a probability question, don't forget to check and see if it's binomial. That's all that goes on to say. You just make sure. If you see a probability question, have in the back of your mind, I got to remember to check and see if it's binomial. Because if it's binomial, I've got 5 formulas that are going to tell me what to do. Okay, so let's check these. Is that it?
No.
Alright, let's check these real quick. You should be able to move quickly through them and see which ones are binomial and which ones aren't. There we go. You roll a fair die 10 times and let x equal the number of 6s. Is it binomial?
Yes.
You have to get 6 of them.
Do what?
Just according to
Alright, you're rolling a set number, so there's n.
Probability of getting a 6 each time is the same.
Correct.
We get 6 of them.
Correct. And is it independent? Yeah. So Greg, what you're talking about is you're looking for here, I would need to ask you like 4, right? But it is a binomial set, right? I just didn't put an exact number here. So if I asked you x is and said some number of 6s, then yes, it is binomial because it meets bins. Does that make sense? So when we actually ask the question, we'll be asking some question, x is 4, or x is 2, right? 2 standing for the number of 6s I see. What's the probability that if I roll it 10 times, I see 4 6s, or I see 2 6s? So yes, this would be binomial because it meets binary, it meets independent because it says fair. Set number of times, yeah, 10. Probability of success is the same every time, yeah, because it said fair. Okay? Does that make sense? Shoot a basketball 20 times from various distances on the court. Is it binary? Yeah, either make it or you don't, right? Is it independent? If you believe what we said earlier in the class, right? That you shooting stays accurate throughout your career until your shooting percentage changes. So if you agree with that, yes. Number, are there a set number of shots?
But what happens if you don't agree with it? Then you just get this one wrong.
What you've got to do is just agree with that through this course.
Yeah.
Whether you agree with it or not.
Well, I don't care.
Yeah.
But
If you disagree with it,
What,
you
we're
should
going
go
to
into
test?
statistics, prove it wrong, and then next time I teach a class, I'll go, as proven here. It's true. So, there's 20 trials, yes, but then check out the probability of success. It says you shoot a basketball 20 times from various distances on the court. Is the probability of success the same every time? No. No, it's not. Probability is going to change. If you're underneath the basket, your probability is higher than outside. So no, this would not be a binomial setting. It has to meet all 4, B-I-N-N-S. Observe the next 100 cars that go by and let C equal color. Is it binary? No, you can't equal the color. Alright, you're just counting like the number of blues. It said that. B equals the number of blue cars you see, then that's binary. It's either blue or it's not. So if we just say color, it could be many different colors. It's not successive color. Alright. Let's look at an actual example. many games involving dice, rolling doubles is desirable. Rolling doubles means the outcome of two events are the same, such as 1 and 1 or 5 and 5. Probability of rolling 2 dice is rolling doubles when rolling 2 dice is 6 out of 36. If x equals the number of doubles in 4 rolls of 2 dice, then x is binomial with n equals 4 and p equals 1/6. On the AP exam, I'll give you that last sentence. And that's where people mess up. They don't tell you it's binomial. They go straight down here to this question and just say, what's the probability that all 4 rolls are not doubles? And then you start trying to write some density curve and figure out what the mean is. And you have no idea how to do that. So you've got to get in the habit of checking and saying, okay, is it binomial? If I don't know what to do, if I'm confused, if I'm having a hard time, and it's a probability question, let's check and see if it's binomial. So if we said 4 rolls, we know the number's set, right? Is it binomial? Yeah, you either roll doubles or you don't. Is it independent? Yeah, if they're fair dice, I would assume that when I roll one time, the next roll isn't going to change. Is the probability of success the same every time? Yeah. Every time I roll 2 dice, I have the probability of 1 out of 6 of getting doubles. So then let's construct the probability distribution. Y'all remember probability distribution? It's all the possible what? Outcomes and what? What's a distribution?
How many times it
And how many times they happen.
Alright, but if it's a probability distribution, then it's not how many times, it's the probability each one has. So let's go through it.
Got 'em.
Right here. If you're asked to make a probability distribution, what you gotta do? What's the probability of rolling 0 doubles?
Tell me more.
Scary. There's like 2 chapters you got. Maybe 1 chapter you got.
If you roll it twice,
4 times. Probability of rolling no doubles.
7/6.
What?
7/6.
Where are you getting 7/6 from?
Because 1/6 is the probability of rolling a double. So 7/6 would be like the probability of like not rolling a double.
7/6. So the probability of rolling no doubles.
Oh, I'm
7/6.
sorry. I was like 5/6. Yeah,
There's
sorry.
100%,
I know.
100% chance. Don't play that game.
I didn't say 5/6.
5/6. Where are you getting 5/6 from?
Since 1/6 is the probability of rolling a double, then 5/6 would be the probability of not rolling a double.
If 1/6 is the probability of rolling doubles, 5/6 is the probability of not rolling a double, right? But what does this 0 stand for? Not rolling a double in 4 rolls. So you gave me the probability of not rolling a double what? In 1 roll. So what's the probability out of 4 rolls of not rolling doubles?
Do you like?
Nick is setting you up to give the right answer.
Do you do?
Tell me how to find it, not the answer.
Do you do it to like the 4th?
Or do what to the 4th?
7 or 5, 6.
5/6. It'd be 5/6 to the 4th. Why? 5/6 is the probability of not rolling doubles. So we need to not roll doubles 4 times. Why are we allowed to just multiply them? Because they are independent. It was last chapter. You gotta know how to do last chapter to do this chapter. Andy?
Oh, wait, never mind. It says 2 dice. I thought it was 1. I was thinking, how do you roll a double?
You
Die.
It'd be pretty hard.
Let's go to 1. Probability of rolling 1 set of doubles out of 4 rolls.
One six, and then 5/6.
What'd you say? 1/6, and then you fade it out.
And then you do something like 5/6 to the 3rd,
1 to the 3rd.
because the other 3 times you're not going to get a double.
So you gotta have a total of 4. 4 rolls. There's 1 roll, 3 more rolls.
Spread it out.
Let's go to 2.
One six
36.
squared.
Come on, man.
I brought up July 8th, but just 2 seconds.
2 seconds? Can you wait 2 minutes?
Sure.
Okay. You don't have to wait outside, you can wait in that chair. 1-6 and 5-6. You agree with that?
I agree.
So then over here it's what?
1-6.
6 to the third times 5, 6.
And then over here?
1 6 to the fourth.
Anybody have a problem with what I've written up there?
No.
I think there's a problem.
Just because I asked that question?
Yes.
It's a good thought. Question is it right or not?
That's
Hang
not
on.
the way to
Hang on.
There's not a problem.
There is a problem.
There is.
Does it have to do with negative multiple?
How many ways can you get no doubles?
Oh yeah, because
One
a
way.
fraction.
Let's do this. Success or failure. Doubles is a success. And failure is no double. So if you think about this, the probability of getting no doubles would be failure, 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 failure. Everybody agree with that? How many ways could you get one set of doubles?
4.
Why 4?
Because you can get it once, you get it twice, you get it 3
Well,
times.
no. Listen to what you said. Katie said you get it once, twice, no. We said only once.
Oh.
You could get it on the first roll, or you could get it on the second roll, or you could get it on the third roll, or you could get it on the fourth roll.
Oh, no.
So this probability is multiplied by 4. There's 4 different ways of that happening. So there has to be a 4 there. How many ways could that happen? A lot. That won't be an answer you want to put. You may go.
You put multiplied by a lot.
Oh my god.
First two.
What?
We went to the creek. I was late to class.
I'm going to the creek 4th period.
If you get a chance, you can like go kick around in the creek. Are you gonna do it?
Hey.
If you get a chance?
Wait, what do you mean kick around?
They give you waders and
Why don't I just
you
like
get
go
to
in your
go kick
jeans?
for bugs. I mean, they gave us that option, but no one.
But if you want to do afternoon, you can. It doesn't matter. Tuesday, Wednesday, Thursday, Friday, and it's after break.
When are you doing
I don't know how to sign up yet. Thursday morning, first one, 7:35. Okay.
You'll get sent to room. Alright, fine. You should sign up to interview with him. You might. Let's see. You get it because they're not? Yeah. They're at the top of the stairs over here. Gross. Wait, that's not enough? No. Wait.
Wait, Clark, can you just come here?
What?
Can you just put it through there?
Did you ever get the kid?
No.
You take them? He did.
I didn't take them. I didn't even know anyone took them, so I came back.
No. Please, come on.
You did take them.
What?
That's so strange. You took them. Did you like drop them or something? I didn't take them. It just, I'm like that serious. I didn't even know they were gone.
The high today is 70. I know. And then I know it's gonna be cold after today for like a couple days.
Alright, we're picking up.
You said you can't go in.
So if you notice, there were 4 options where you could get 1 success. There'd be 6 options where you could get 2 successes. There'd be 4 options where you could get 3 successes because there's only 1 failure, right? So it's kind of ranked out. And then there'd be how many options would you get all successes? 16 ways to get 4 successes? 1. S, 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 S. Now, so notice those numbers. Something like this. Maybe that'll point you where we're going.
Oh, Pascal's triangle.
Pascal's triangle.
Oh no.
Pascal's triangle. Now, you won't have to make Pascal's triangle, but it's from Pascal's triangle. Because if you notice, how many trials were there? How many trials were there? 4, right?
Alright.
So we go to that 5th row. So if you remember Pascal's triangle, it looks like this. And so we counted them back when you were in Algebra 2. You went like that was row 1, 2, 3, 4. N equals 4, N equals 3, N equals 2, N equals 1. But I don't expect you to do that because what if I said N equals 25? Right? You flip the coin 25 times, what's the probability of getting 15 heads? You don't want to go down and make a 25th row there. You spend the whole test just making Pascal's triangle. So here's what you need to understand. Your calculator will find each one of these numbers for you. You have to tell it 2 things. You have to tell it how many trials there are, how many trials there are, and how many successes you want. How many trials and how many successes. So, if you would, look back at your formula sheet again. numbers just stood for how many successes there were. There was only one way in 4 trials to get, there's only one way in 4 trials to get no successes. There were 4 ways in 4 trials to get 1 success. There were 6 ways in 4 trials. And just without putting n equals 4, x equals 2. N equals 4, x equals 3. N equals 4, x equals 4. There's only one way in 4 trials to get 4 successes. So each one of those numbers just stands for how many different ways. You may know what word you could replace with ways. How many different what?
Outcomes.
Yeah, another word I'm looking for though. What are these all? These are all just different what? Combinations. These are all different combinations of the same thing. 2 successes. There are 6 different combinations of 2 successes. Okay? So you learned how to do combinations at some point, maybe, in Algebra 1. And they look like this on the calculator. The way they write them on the formula sheet is like this. But the formula sheet doesn't use the letter R. The formula sheet uses the letter K. So what I'm telling you right now, if you're not following this, is this. The calculator will give you any one of these numbers you want from Pascal's triangle going down as far as you need to go. You just need to tell it how many trials there are and how many successes we're looking for. How many trials and how many successes. So that's what it says on the calculator. What you're putting there is number of trials and then the number of successes you want to see. And what that's going to equal is how the number of combinations of that outcome. All right? There were 6 combinations with the outcome 2 successes. Here's where you go. Math. And then if you go all the way to the right, you see probability. And then you should see that right there. NCR. You see NCR there. I'm going to go ahead and replace that with a K because that R right there means K. On your formula sheet, they don't use an R, they use a K. That's how you find combinations. So, if I asked you, this isn't what they're going to ask on the test, but if you understand it, you'll be able to use it. If I said, okay, let's say you flipped a coin, fair coin, 65 times. What is the probability of getting 13 tails? Now let's think about this because what you guys did on the notes is great. You just needed more information. So let's start with just the probability part. What would be the probability of getting 13 tails and 65 flips of a fair coin? How would we find that? What's the probability of getting tails?
50%.
50%. How many times do I want to get it? 13 times, right? And then I want to not get tails 52 times, right? Does that make sense? What's the probability of not getting tails? 50%. 52 times. How many different combinations are there of getting 13 tails out of 65 trials? A A lot, but we need the actual number. How do you get the actual number? You're going to use that formula, but here's what you need to know. That formula, you don't hit it first. You hit them in this order. So the first thing you've got to do is type in the number in your calculator of the number of trials. So how many trials did I have there? 65. So go ahead and hit 65, then go to math. How many successes do I want? 13. We read that as 65, choose 13. We're going to read that correctly. It says 65, choose 13. Multiply that number by those probabilities. You get the probability of getting exactly 13 tails and 65 flips. And if you notice, that's the formula on your formula sheet. The probability of getting $13 tails and 65 flips. After you get that number, which will be huge, there's lots of different ways that you could get 13 tails out of 65 flips. It could be the first 13, it could be the second 13. It could go tails, heads, and then 12 tails. Right? There's lots of different ways. So that's going to be a giant number. But when you multiply it by that probability, it should change.
It goes like a lot. It goes like 4.451 to the 10 to negative 7.
10 to the negative 7. So there's a...
I don't know if that's right though.
I don't know which way So you got when you did that times that? Yes. So 10 to the negative 7, so it'll be 0, 0, 0, 0, 1, 2, 3, 4, 5, 6, 7. 4.5 something?
Yeah, 4.4509.
Yeah, that sounds low.
Wait, so you're saying on the
Oh,
second?
no, it doesn't. It doesn't sound low.
It's 13 out of 65. Exactly 13? Or,
Uh-huh.
Yeah. So.
Why would that not be low? I get why we started to think it would be low. How many would we expect to see?
50%.
Around 50%, right? Not exactly, but around 50%. So we'd expect to see around 32 or 33, maybe 27 to 37, right? So the probability of seeing 13 and it actually being a fair coin, real low. It's very unlikely you'd have 13 tails if it's a fair coin. Is it possible? Certainly. But it's very unlikely. Yes, sir.
So you were saying on that second line that
Here?
after you get the number for 65, choose 13, then you have to multiply it by that. And
Yes,
then
sir.
You get it.
Because that's all of the possibilities the way 13 tails could show up. And then we've got to say times the probability.
What does that final number represent?
This?
Yeah.
The probability of getting 13 tails and 65 flips. So there's like less than, way less than a 0, or not less than a 0, but close to 0% chance of it happening. If it's really a fair coin.
Of what, getting 13 and 65 times?
13 tails out of 65 flips.
Oh, exactly.
13 tails out of 65 flips. So look at that formula sheet. Make sure you understand it. Make sure you know how to do it. Make sure you know how to do N choose K. Because they won't put NCR on the test. So that formula will always be there. That's a combination. So these formulas that we wrote on the board are not correct. That would happen 1 time, no need to add the 1. That happens 4 times, 6 times, 4 times, 1 time. So what's the probability that all 4 rolls are not doubles? Are not doubles? It's just 5/6 to the 4th. Right? We said that. And that can only occur one way. So that's why there's no number multiplying in front of it. If you did 4 choose 0, you're going to get 1. I'm not getting any blanks there. Do it for a minute. these numbers didn't make sense to you, the 4, the 6, and the 4, hopefully the next set of blanks will help it make sense. Can I move forward? So if I say, what's the probability that x equals 1? Exactly 1 of your 4 rolls of 2 dice would give you double. The probability of that happening is equal to the probability that you get on the first roll plus the probability that you get on the second roll plus the probability you get on the third roll plus the probability you get on the fourth roll. Those are the 4 different combinations of ways that you can get only one success. Incorrect. Don't do the probability of x equals 4 completely. Go ahead and fill it in, but don't type it in your calculator. If you get the right answer, type it in your calculator on 2 1/3. Make sure you're showing the work. If you on a test wrote probability of x equals 2 and then gave me a percentage, you would get no credit. You gotta tell me how you got the percentage. Show the work, use the formula sheet. Just plugging in into the formula in the formula sheet. Four times. That's just the number of trials. So if I said we're gonna roll it 15 times, that'd be 15. Did 11.57% here. Is that right? Okay, now here's what I want you to hear. If you got 11.57% here, you know how to do it. I would never do it that way again. But here's why I made you do it that way. You've got to write it this way on the test. This is what they're going to want to see. So write it, plugging it into the formula given to you on the formula sheet. But then there's a much quicker way to get that answer from the calculator. What are we dealing with here, this whole section today? Binomial probabilities. And we find binomial probabilities from a binomial what? Distribution. This is a distribution. What's the only distribution we've worked with much this year? Normal. We've got a new one. What did you do if you wanted to find probabilities with normal distributions on the calculator? Normal CDF. Where was normal CDF? Distributions. It's under distributions. It'll be real helpful. Obviously, you don't have to know what I'm about to show you how to do because you've already got the right answer. So if you want to do it that way, you're fine to. But it takes you longer to do it that way and type all that in than it does what I'm about to show you. If you would, go to second VARS, that's distributions. Just like how you went to normal PDF and normal, well, you've only used normal CDF. If you scroll down, you're going to see two binomial distributions. Binomial PDF and binomial CDF. You got to know which one to use. With normal, we only use CDF. It's the only thing we ever use. With binomial, because binomial can be discrete random variable, we've got to be able to determine if we want to use PDF or CDF. Do you remember what I told you the C in normal CDF stood for? No, way back when. Nope. Normal CDF, way back when. Cumulative. It was everything to the left. Do you remember that? When you did normal CDF, you did everything to the left with everything in between your lower bound and upper bound. Remember this? Okay. So right here, am I doing everything or one value? Finding the probability that x is less than 2 or equal to 2? Equal, right? So that's not a cumulative. So if you were ever doing probability of x equals one number, you'll do binomial PDF. Go ahead and click that, binomial PDF. Most of your calculators, it will prompt you. And it'll ask for the number of trials. How many trials happened here? 4. So go ahead and put in 4. And let's do the next problem. It asks for P. What does P stand for? We wrote it down earlier in the notes. What is it? Probability of success. What's your probability of success? 1/6. So put 1/6 there. If you're still not where we are, we went to second VARS, which is distribution. We went to binomial PDF because we want to find a certain value. We typed in the number of trials 4, the probability of success 1/6. And if I was doing this problem, how many successes do I want? 3. Hit 3 and hit enter. And it should give you the exact same answer all of you already got. 0.0154. 0.0154. You don't have to do that. You don't have to use that method, but to me, that's a lot quicker than having to go type that in, and that in, and that in. All you have to type in is number of trials, probability, and whatever you want X to be. Up to you if you use it or not, but I need to see you plug it into the formula to get full credit. So I'll answer questions on how to get there. Joan, did you have a question?
No.
So why don't you go ahead and try 4 and make sure you get the same answer that you already got if you've already done 4. If you haven't done 4, make sure you get an answer that we all get. Hey, on 4, are we going to do PDF or CDF?
PDF.
Still PDF. We're not saying the probability that X is less than 4. We're not saying cumulative, everything up to 4. We're saying 4 exactly. You should have gotten 0.00077. So 0.077%.
Can you put the binomial PDF in the numbers as your work, or do you have to have?
Say that again.
Can you put the what you plug into your calculator as your work?
If you label them correctly, but I'd use that formula. They give you a formula on the formula sheet, I'd use it. Anytime you've got a formula from the formula sheet, I'd use it. With the normal CDF, there's not really a formula for that, right? I'm using table X.
Yeah.
If they give me a formula on the formula sheet, I'd use that. But yes, you could write binomial PDF. If you wrote CDF, you're wrong.
Yeah.
Binomial PDF, comma, or open parentheses, 4, comma, 16, comma, 4 in this case, but then you have to tell what those are. All right, 4 is N, 16 is P, X, or K is 4 in this situation. Everybody understand how to use that? Any questions there? All right, we're going to stop in 2 minutes. I'm going to let you get through. That's the formula on the formula sheet. No need to write it down. Okay? If you need to fill in any blanks, fill in any blanks you got. I've already given you all of that. Anything from there? I'm going to jump to one kind of problem. Right here. Look here with me. So it's the second question on your page of notes. Okay? Second question says, find the probability that at least 3 of the 5 children have typos left. Let's go ahead and figure out what that would be. That'd be the probability that X is what? Greater than or equal to 3. Right? Greater than or equal to 3. Which is the same thing as what?
X is less than
1 minus probability of what?
less than 3.
Less than 3. Alright, here's where you gotta be careful. I'm gonna spend a few minutes. I don't know if this is gonna be a little more than 2 minutes before we get to it. Your calculator, when you do that on the calculator, it always does. So when I go to PDF, I'm sorry, CDF, CDF is cumulative. Everything up until, right? Does that make sense? Everything up until that. Everything up until that. If you did this right here, watch with me. If you did 1 minus, we want to do CDF now, right? It's not PDF anymore because it's all the way up to 3. It's cumulative. Everything less than 3. So we'd go CDF. Please pay close attention into what would be wrong. How many trials are there here in this situation? If you need to read the question, read the question. How many trials are there? 5. There's 5 kids. So I'm going to start with 5. That'd be good. Doing everything right so far. What's the probability of success here? What's the probability of having type O blood? 25%. So you're still doing everything perfectly. How many do I want to see?
At least.
All the way up to what?
2.
3, but not including 3. All the way up to 3, but not including 3. So what should I say? Or what are we talking about here?
Kids.
Kids. This is what kind of random variable? Discrete. On discrete random variables, you have to be careful. If you put 3 right here, you're wrong. Because it's going to find all the way up to 3. But we don't want to include 3, and there's nothing between 2 and 3. So your calculator always finds all the way up to that value. So, what do we want to know? To 2. So I get in the habit of writing right here. Because it's discrete, there are no numbers between 2 and 3. If this was continuous, we'd go all the way up to 3. But there are no numbers there, so that right there, x has got to be less than or equal to 2. When you're dealing with binomial probabilities, then make sure you've always got an or equal to sign. So if they say less than 3, you need to be less than or equal to 2. That way you don't mess up here. Alright, this is where we'll pick up after your presentations finish up on Friday or Monday. And we'll get all the way through binomial distributions. Okay? So you've got about 22 minutes to make any final, whatever you need to do, alterations to your project.
You mean you're fat?
Determine some times to meet tonight. Couple quick reminders. Might just have one. Your group will go one of the first groups if you do not have anybody in the orchestra, because they'll go the second half of the class. If you get up here and read off the board, or read off a sheet of paper, or talk so quietly we can barely hear you, or don't say a word, your group will lose points. Everyone should be contributing. So make sure you know what you're talking about. You don't get up here and go, oh, it's my turn. For a particular family, the chance that a child has type O blood. Okay? If you need to memorize something, then come up here and read it off, but it needs to look like you're talking about it. Make a good presentation. I won't grade you super strict on that this time, but I will in the final presentation. The way you can practice. Get the rest of class. Make sure you either come tomorrow with a flash drive or that you have emailed me or somehow gotten me access to your presentation so I can